Hello, this video is on lesson 10-2. It begins on page 163. The learning targets here are to explain why 3 points are needed to determine a parabola, determine the quadratic function that passes through 3 given points on a plane. Recall that if you are given any 2 points on the coordinate plane, you can write the equation of the line that passes through those 2 points. The 2 points are said to determine the line because there's only one line that can be drawn through them. So what that is saying is that if I have 2 points, how many lines can I draw that goes through those 2 points? There's only one line that can go through those 2 points. Compare that with just 1 point. If I were to just give you 1 point, how many lines can go through that 1 point? As you can see, there are a lot of lines that can go through that 1 point. Compared to just 2 points, only one line can go through those 2 points. So those 2 points are said to determine the line. All right. The 2 points on the coordinate plane determine. Do 2 points on the coordinate plane determine a parabola? To answer this question, work through the following items. So what that is asking is that, let's say we are given 2 points. Is there just one parabola that is able to go through those 2 points? Well, let's answer that question. Follow the steps to write the equation of a quadratic function whose graph passes through the points 2, 0, and 5, 0. Alright, so those are the 2 points we're given. Write a quadratic equation in standard form with the solutions x equals 2 and x equals 5. So again, we're given the point 2, 0, which can be, and notice that my y-coordinate is 0 for both of these. That means that these are the solutions to the quadratic function, x equals 2 and x equals 5. So if I set each of these equal to 0, I can go ahead and multiply the factors out to find the equation of the quadratic function. So x times x gives me x squared. X times negative 5 is negative 5x. Negative 2 times x gives me negative 2x, and negative 2 times negative 5 gives me positive 10. So we have x squared minus 7x plus 10 is equal to y, or y is equal to this equation. Now what it says is to replace 0 in your equation from part A with y. Write the corresponding quadratic function. So that's what we have. Graph your quadratic function from item 1 on the graphing calculator. On the same screen, graph the quadratic functions, these 2 quadratic functions. Alright, so let's go ahead and graph this. First equation was x squared minus 7x plus 10. Go to menu, graphs, x squared minus 7x plus 10. Notice it goes through those 2 points, 2, 0 and 5, 0. Now let's go ahead and graph these other 2 functions that it gives us, which are right here. So I'm going to hit tab. Y equals 2x squared minus 14x. Didn't quite finish there. 2x squared minus 14x plus 20. And then let's go ahead and graph the other one. Negative x squared plus 7x minus 10. Now take a look at that. Can you see that my two given points are right here? This is 2, 0, and this point right here is 5, 0. So going back to the original question, do 2 points determine a parabola? Can only one parabola go through those 2 points? No. As you can see, we have 1, 2, and 3 parabolas already going through those 2 points. And so that answers that question. Do 2 points on the coordinate plane determine a parabola? No. And you may want to provide an explanation. 3 points in the coordinate plane that are not on the same line determine a parabola given by a quadratic function. If you are given 3 non-collinear points on the coordinate plane, you can write the equation of the quadratic function whose graph passes through them. So here's what we determined. Given 2 points, only one line can go through those 2 points. And if you're given 3 points, only one parabola is able to go through those 3 points. Now there's something important about those 3 points. Those 3 points have to be non-collinear. That means that those 3 points cannot lie in a straight line. What if they happen to lie in a straight line? So here we go. Here are 3 points that lie in a straight line. Is it possible for me to draw a parabola that goes through those 3 points? No, there's no way. You might be tempted to do this. Well, it goes through those 3 points. This would be wrong. You're saying that from this point to this point, basically the parabola acts like a straight line, but that's not part of the property of a parabola. A parabola is always going to be curved in every single part of its graph. And so the 3 points have to be non-collinear, which means they have to not lie in a straight line. And if I have that, that means I can draw a parabola that goes through those 3 points. Alright. Now, here's what we're going to do, the main part of the lesson. Consider the quadratic function whose graph passes through the points 1, 2, 3, 0, and 5, 6. Write an equation by substituting the coordinates of the point 1, 2 into the standard form of a quadratic function, y equals ax squared plus bx plus c. So here's the standard form of a quadratic function. What I want to do is I want to take each point, let's start with 1, 2, identify the x and the y coordinates. 1 is x, 2 is y. Once I find that, I can go ahead and substitute x and y into the standard form of the quadratic equation. So instead of writing y, I'm going to substitute in 2 is equal to a x is 1 squared plus b times 1 plus c. So as you can see, we have our first equation. Simplify that a bit. 2 is equal to a plus b plus c. And since we have 3 points, we want to do that for each one. So here we have 3, 0. 3 is x and y is 0. Again, we want to substitute those x and y's into my standard form of quadratic function. So we have 0 is equal to a 3 squared plus b times 3 plus c. What I can do is simplify this. 3 squared is 9, so I have 9a plus 3b plus c. And then finally, I have my last point, which is 5, 6. And let's just go ahead and quickly substitute that in. We have 6 is equal to a times 5 squared plus b times 5 plus c. If we simplify this, we get 6 is equal to 25a plus 5b plus c. Here are my three equations. So I basically did 5 and 6 already. Now, use your equations from items 1 through 6 to write the system of three equations in three variables a, b, and c. Let's use Gaussian elimination to solve the system for a, b, and c. So remember, where do we get these from? Well, those are basically these three equations right here. 1, 2, 3. So I can see this is what we have, and what we want to do is use Gaussian elimination to solve for a, b, and c. Once we have a, b, and c, what we can do is plug them into the standard form of a quadratic equation, and that is going to give us the quadratic equation that goes through these 3 points. And there's only one quadratic equation that is capable of going through those 3 points. So let's begin. First thing I want to do is I want to take equations 1 and 2 plus b plus c equals 2. Let me use some technology here just to make it easier. So there are equations 1 and 2. Now if I add these together, notice I get 10a plus 4b plus 2c equals 2. Now nothing gets eliminated, and that's the whole point of elimination. I want to find what variable can I eliminate when I add them together. So instead, what I'm going to do first before I add them is I want to multiply everything in the first equation by -1. So what do I get when I multiply everything by -1? I get -a minus b minus c is equal to -2. And let's go ahead and write the second equation the same way. Plus c equals 0. And I'll take a look at what happens when I add them together. -a plus 9a is 8a. -b plus 3b is 2b. And take a look at this. -c plus c becomes 0. And so we don't have to write that down, and we get -2 plus 0 is -2. As you can see, we have this result, and what we ended up doing is we eliminated c. We eliminated c. Okay. So we're going to stop there because we need another equation that looks like this. And what we need to do is, since we already used equations 1 and 2, let's go ahead and use equations 2 and 3. So let me use some technology here. So here are equations 2 and 3. Now, you want to go ahead and add them together to see if anything automatically eliminates itself. So here we have 34a plus 8b plus 2c equals 6. Now there's something important. We have equations 2 and 3. Now remember, from equations 1 and 2 we eliminated c. We also want to eliminate c here. We can't decide to eliminate anything else. We want whatever we do with the first two equations, we have to do with the other two equations here. So in order to eliminate c, if we add them together, we just get 2c. Now this is going to actually be pretty simple because we just have to just multiply one of them by -1 in order to eliminate c. So let's just multiply equation 2 by -1. What we get is -9a minus 3b minus c is equal to 0. We didn't do anything with equation 3, so we'll just go ahead and write everything the same. Okay, so let's go ahead and add these together. Here we have -9a plus 25, and so that's going to be 16a. -3b plus 5b, well, that's going to be plus 2b. The c's get eliminated, which is what we wanted to do, equals 6. Okay, so take a look at this now. Here are the two equations that we want to concentrate on now. Those are the two equations. So let's just call these equation 4 and equation 5. And let's go ahead and write them right on top of each other. 8a plus 2b equals -2. 16a plus 2b is equal to 6. Now here, it doesn't matter which one you eliminate as long as you eliminate a variable. So it can either be a or b. Looks like we can eliminate b by simply multiplying one of them by -1. So if we multiply the top one by -1, we're going to get -8a minus 2b is equal to +2. We didn't do anything with equation 5, so we're just going to write everything the same. And now let's go ahead and add these together, and we're going to get -8a plus 16a, which is going to be 8a. The -2b and +2b, though, that cancels out, and so we get 2 plus 6, which is 8. Now let's go ahead and divide both by 8, and take a look at this. We get a is equal to 1. Notice that at the very beginning we want to solve for a, but we also want to solve for b and c. So once I get that a is equal to 1, now I can use a to plug it in either into equation 4 or equation 5. It's going to be your choice. Let's go ahead and plug it into equation 4. So equation 4 is right here. And if I plug in a, which is 1, I get that 8 times 1 plus 2b is equal to -2. And guess what? I just have the variable b, which is what I can solve. So I have 8 plus 2b is equal to -2. Subtract 8 from both sides. And so we get 2b is equal to -10. Divide by 2, and we get that b is equal to -5. Alright, we're getting closer. We have a and b, and now what we can do is take a and b and plug it into one of these 3 original equations. And so let's plug it into the first one. So we have a is 1 plus b, which is -5, so I just have 1 minus 5, plus c is equal to 2. Let's simplify that. What is 1 minus 5? Well, that's -4 plus c is equal to 2. Let's just do some simple math here by adding 4 to both sides, and so we have c is equal to 6. There we go. We solved the system using elimination. Now what I can do is use this equation right here. So question number 9, now substitute the values of a, b, and c into the standard form of the quadratic equation. Standard form of quadratic equation is y equals ax squared plus bx plus c. And all I have to do now is just plug it in. A is 1, x squared, plus b, which is negative 5, x plus c, which is 6. Let's just simplify everything. Y is equal to x squared minus 5x plus 6. Here is my quadratic equation. And if you graph that, you're going to see that these were the original points that we were given at the very beginning. 1, 2, 3, 0, and 5 and 6. If we put those points on the grid and we graph this quadratic function, we can see that our parabola is going to go through those 3 points. So those 3 points determine this specific parabola. All right. So your homework is questions 14 through 16 through 19 on page 166. Thank you for watching.